Using resources wisely. Why is soil important and how do we protect it? Healthy soil supports both agriculture and forestry. It is possible to minimize soil erosion through careful management of both agriculture and forestry. The mineral and nutrition rich portion of soil is called topsoil. Good topsoil absorbs and retains moisture, yet allows water to drain. It is rich in organic matter and nutrients, but low in salts. Good topsoil is produced by long term interactions between soil and the plants growing in it. Years of poorly managed farming, in addition to severe drought in the 1930s, badly eroded the once fertile soil of the Great Plains. The area essentially turned to a desert or a dust bowl. Soil erosion is the removal of soil, organic matter, and minerals by water or wind. Soil erosion is often worse when land is plowed and left barren between plantings. When no roots are left to hold the soil in place, soil with the organic matter and minerals is easily washed away. So, soil holding crops are now sowed to help avoid erosion in the off season. When topsoil is removed, it exposes an underlayer that may be more vulnerable to more extreme erosion. However, you will notice some topsoil building at the bottom of the trench. Deforestation, or the loss of forests, can have a negative effect on soil quality. More than half the world's old growth forests, forests that have never been cut, have been lost to deforestation. Healthy forests hold soil in place, protect the quality of fresh water supplies, absorb carbon dioxide, and help moderate local climate. In some areas, forests can regrow after cutting, but it takes centuries for succession to produce mature old growth forests. In some places, forests can't grow back at all after logging. This is why old growth forests are usually considered non renewable resources. Deforestation can lead to severe erosion. Grazing or plowing after deforestation can permanently change local soils and microclimates in ways that prevent the regrowth of trees. For example, when tropical rainforests are cleared for timber or for agriculture, their soil is typically useful just for a few years. After that, the areas become wastelands. The thin topsoil and the high heat and humidity prevent regrowth. Leaving stems and roots of the previous year's crop in the soil can help hold soil in place between planting. Also, crop rotation, planting a different crop at different seasons or in different years, can help prevent both erosion and nutrient loss. Selectively harvesting mature trees can promote the growth of younger trees and preserve the forest ecosystem, including the soil. A well managed tree farm both protects the soil and makes the trees themselves a renewable resource. The practice of contour plowing or terracing involves planting fields and crops across instead of down the slope of land. This can reduce water runoff and therefore reduce erosion. What are the primary sources of water pollution? The primary source seems to be industrial and agricultural chemicals, residential sewage, and non point sources. Humans depend on freshwater and freshwater ecosystems for goods and services, including drinking water, industry, transportation, energy, and waste disposal. Some farmland relies heavily on irrigation, in which fresh water is brought from other sources. Some sources of fresh water are not renewable. The Ogallala Aquifer, for example, spans 8 states from South Dakota to Texas. The aquifer is not replenished by rainfall at the rate of use today. At the current usage rate, the Ogallala Aquifer is expected to run dry in 20 to 40 years. Only 3% of the Earth's water is fresh water, and most of that is locked in ice on the poles. Freshwater sources can be affected by different kinds of pollution. A pollutant is a harmful material that can enter the biosphere. Pollutants that enter water supplies from a single source, a factory or an oil spill, for example, are called point source pollution. Pollutants that enter water supplies from many smaller sources The grease or oil washed off the street by rain, or the chemicals released into the air by factories and automobiles, for example, they're called non-point source pollution. Pollutants may enter both surface water and underground water supplies that we access with wells. The primary sources of water pollutants are industrial and agriculture chemicals, residential sewage, and non-point sources. One industrial pollutant is a class of organic chemicals called PCBs that were widely used in industry until the 1970s. After several large-scale contamination events, PCBs were banned. Because PCBs often enter mud and sand beneath bodies of water, they can be difficult, if not impossible, to eliminate. Other harmful industrial pollutants are heavy metals like cadmium, lead, mercury, and zinc. Large-scale monoculture planting has increased the use of pesticides and insecticides. These chemicals can enter the water supply in the form of runoff after heavy rains, or they can seep directly into groundwater. Pesticides can be very dangerous pollutants. The insecticide DDT effectively controls agricultural pests and disease-causing mosquitoes, but some pesticides, such as DDT, are pollutants. When DDT gets into the water supply, a phenomenon known as biological magnification can occur. Biological magnification occurs if a pollutant, such as DDT, mercury, or PCB, is picked up by an organism and is not broken down or eliminated from its body. Instead, the pollutant collects in body tissue. In the process of biological magnification, primary producers pick up a pollutant from the environment, and then the herbivores that eat the producers concentrate the pollutant and they store it 10 times the level of the producers. When carnivores eat the herbivores, the compound is still further concentrated. In the highest trophic level, pollutant concentrations may reach 10 million times their original concentration in the environment. These high concentrations can cause serious problems for wildlife and humans. Widespread DDT use in the 1950s threatened fish-eating birds like pelicans, osprey, falcons, and bald eagles. It caused female birds to lay eggs with thin, fragile shells, reducing hatching rates and causing a drop in birth population. Since DDT was banned in the 1970s, bird populations are recovering. Still a concern is mercury, which accumulates in the bodies of certain marine fish, such as tuna and swordfish. Sewage contains lots of nitrogen and phosphorus. Large amounts of sewage can stimulate blooms of bacteria and algae that rob water of oxygen. Oxygen poor areas called dead zones can appear in both freshwater and saltwater. Raw sewage also contains microorganisms that can spread disease. One key to sustainable water use is to protect the natural systems involved in the water cycle. Protecting these ecosystems is a crucial part of watershed conservation. A watershed includes all of the land whose groundwater, streams, and rivers drain into the same place, such as a large lake or river. Pollution control can have direct and positive effects on water quality in a watershed. Sewage treatment can lower levels of sewage-associated bacteria and help prevent dead zones in bodies of water receiving the runoff. Agriculture can use integrated pest management, IPM, instead of pesticides. IPM techniques include using predators and parasites to regulate pests, using less poisonous sprays and crop rotation. Conserving water is also important. One example of water conservation in agriculture is drip irrigation, which delivers water drop by drop directly to the roots of plants. Tiny holes in water hoses allow farmers to deliver water only where it is needed. What are the major forms of air pollution? Common forms of air pollution include smog, acid rain, greenhouse gases, and particulates, dust. The atmosphere, which provides the oxygen we breathe, is a common resource whose quality has direct effects on health. Ozone, a form of oxygen that is found naturally in the upper atmosphere, absorbs harmful ultraviolet radiation from sunlight before it reaches Earth's surface. The ozone layer protects our skin from damage that can cause cancer. The atmosphere's greenhouse gases, including carbon dioxide, methane, and water vapor, regulate global temperature. Without the greenhouse effect, the Earth's average temperature would be about 30 degrees Celsius cooler than it is today. When the quality of Earth's atmosphere is reduced, respiratory illnesses such as asthma are made worse and skin disease tend to increase. Industrial processes and burning of fossil fuels can release pollutants of several kinds. Smog is a gray-brown haze formed by chemical reactions among pollutants released into the air by industrial processes and automobile exhaust. Ozone is one product of these reactions. At ground level, ozone and other pollutants threaten the health of people, especially those with respiratory conditions. Many athletes participating in the Summer Olympics in Beijing, China, expressed concern over how the intense smog would affect their performance and health. Burning fossil fuels releases nitrogen and sulfur compounds. When these compounds combine with water vapor in the air at high levels, they form nitric and sulfuric acid. These airborne acids can drift for many kilometers before they fall as acid rain. Acidic precipitation can dissolve and release mercury and other toxic elements from the soil, freeing those elements to enter other parts of the biosphere. So, the formation of acid rain, emissions to the atmosphere from industry, transportation, ore smelting, power generation. They release nitrogen oxide and sulfur dioxide. There's a chemical transformation in the air to nitric acid and sulfuric acid. They could fall out as dry particles or gases, or they could be condensed, combined with a condensation, and the precipitation would include acid rain, fog, snow, or mist. In some areas, acid rain kills plants by damaging their leaves and changing the chemistry of soils and surface water. Acid rain can also cause damage to stone statues. Burning fossil fuels and forests releases stored carbon into the atmosphere as carbon dioxide, a greenhouse gas. Agriculture practices release methane, another greenhouse gas. Although some greenhouse gases are necessary, when excess greenhouse gases accumulate in the atmosphere, they contribute to an increase in global temperature. Particulates are microscopic particles of ash and dust released by certain industrial processes and certain kinds of diesel engines. Very small particulates can pass through the nose and mouth and enter the lungs, where they can cause health problems. Most notably, those who worked in mines or cement factories may suffer from lung irritation and disease. Automobile emission standards and clean air regulations seem to be having a net positive effect. The graph on the following slide summarizes EPA findings of the total percentage change from 1980 to 2007 in vehicle miles traveled, energy consumption, and combined emissions for 6 common pollutants. So vehicles traveled, we are traveling more, but the energy consumed does increase, not too much. This is significant. The aggregate emissions for 6 common pollutants has actually gone down. At one time, for example, all gasoline was enriched with lead. U.S. efforts to phase out lead gasoline were completed in 1996 when the sale of lead gasoline was banned. Now that unleaded gasoline is used widely across the United States, lead levels in soils, rivers, and streams around the country have dropped significantly.